Episode 1, Stephanie Kwolek created a cloudy polymer solution that looked ready for the waste bin. She persuaded a cautious technician to spin it into fiber, and the result was lightweight, heat-resistant, and about 5 times stronger than steel by weight. Most people celebrate a successful experiment with coffee. Stephanie had just opened the door to an entirely new category of high-performance materials. Welcome back to Hidden Minds Behind Famous Things. Today, Kwolek's strange laboratory fiber becomes Kevlar, a material used in tires, cables, protective equipment, and machines that travel beyond Earth. We will also answer an uncomfortable question. When your invention becomes enormously valuable, do you personally become enormously rich? Corporate research departments are now staring nervously at the floor. Kwolek immediately understood that the fiber mattered. She and other DuPont scientists studied its chemistry, while a larger team refined production and manufacturing. The material eventually became known as Kevlar and reached the market in the early 1970s. It belongs to the aramid family, short for aromatic polyamides. That name sounds less like a superhero and more like something that politely reminds you to wear safety goggles. Its performance, however, was extraordinary. Kevlar contains long, rigid molecular chains. During manufacturing, those chains align in the same direction. Strong attractions between them help hold the structure together. Imagine people trying to move through a doorway. If everyone is tangled, facing different directions and checking imaginary 1960s smartphones, the group is chaotic. In straight, tightly connected lines, the structure is harder to pull apart. Please do not cite "crowd near doorway" in a chemistry paper, but the basic idea helps. One early goal was reinforcing automobile tires. Steel cords were strong but heavy. A lightweight synthetic fiber could reduce weight while still handling serious stress. Kevlar later appeared in tires, drive belts, hoses, cables, and other industrial products. Engineers looked at its strength, heat resistance, and low weight, then asked the most dangerous question in engineering. What else can we do with this? Was apparently almost everything. Kevlar became famous in protective body armor. Layers of woven aramid fabric can catch and spread the energy of certain bullets and fragments across a wider area. Stephanie did not personally invent the modern bullet-resistant vest. Her fiber made many later designs possible. And body armor does not make anyone invincible. Different products have specific ratings, limitations, and service lives. Please never test one at home. That warning should be unnecessary, but humanity has access to video sharing websites. Kevlar's story extends far beyond body armor. It appears in cut-resistant gloves, firefighter equipment, aircraft components, ropes, brake pads, boats, and communication cables. Strong aramid fibers have also served in aerospace applications. A material inspired partly by the search for better tires eventually helped technology leave the planet. That is an impressive career path. Most tires are fortunate if they survive one badly placed pothole. Kevlar became enormously valuable. So Stephanie must have received a giant personal fortune, correct? No. She was a salaried corporate researcher, and patents connected with the work were assigned to DuPont. She did not receive royalties from Kevlar's commercial success. This arrangement was common and legal. It was also the kind of ending that makes an audience stare silently at the screen. Her satisfaction came largely from knowing the material helped protect people. A royalty check would not have damaged the story. Recognition eventually arrived. Kwolek entered the National Inventors Hall of Fame in 1994. In 1995, DuPont awarded her its Lavoisier Medal for outstanding technical achievement. She was the first woman to receive it. In 1996, she received the National Medal of Technology. She also encouraged young people, especially girls, to study science. Stephanie wanted the next generation to find more open laboratory doors than she had, preferably doors reinforced with Kevlar. Kwolek's discovery is often described as accidental, but accident is only part of the story. The cloudy solution was unexpected. Recognizing its importance required training, patience, and courage. She noticed a pattern others might have ignored. She insisted on testing a mixture that looked wrong. Luck may open a laboratory door. Science still has to walk through it, collect the data, and write everything down before someone cleans the bench. Stephanie Kwolek did not set out to create body armor. She was searching for a better industrial fiber and discovered a material that transformed protection, transportation, and engineering. Kevlar has helped safeguard countless people and strengthen technology on Earth and beyond. It began when one chemist looked at a cloudy liquid and said, "Wait, this is interesting." This hidden story, like the video, follow the channel and share it with someone curious enough to test an idea twice.